we did some easy substitution problems. I kind of would like to start the other way around. Let's chunk it. I think that you guys are having a more difficult time remembering how to graph than you are doing this part. So maybe you should start with the graph and then try and do the substitution. So let's start with graphing this. Let me graph this one first. So this is a line, right? It's linear. So y equals 2x plus 5. I'm going to go up 1, 2, 3, 4, 5. And up 2 over 1, up 2 over 1. Down 2 over 1. That's the line. Then this one is a what? That's a parabola. It's quadratic. We'll just pick parabola. That is a parabola. We know certain characteristics of this parabola. The parabola has a vertex, right, at 2, 9. So I'm going to go to 2, 9. 1, 2, 3, 4, 5, 6, what? 2, 9, right there. There's my intersection. I already have it. See where it intersected right there at the vertex? So then I've got 2, 9. So then I know my parabola is pointing down, right there. I know my parabola is 1 wide. So the LLR, the width of it, I don't even know why we call it the LLR. I'd rather just call it the width. I know it's the lattice rectum. You just wanted me to say that on recording one more time. So the width of our parabola is 1. So P, the distance from the vertex to the focus and from the vertex to the directrix, has to be smaller than that, right? It's smaller by how much? Not by half. What's that magic number? 4. It's smaller by a fourth, right? So if I want to know P, I just have to take 1 and divide it by 4. That's kind of a small graph to do, right? But that's okay. It doesn't matter because we're just looking for the intersection. So when I do that, I'm going to have 1/4. Let me do a different color so you guys can see it. We'll just say 1/4 right there, right? And 1/4 right here. That would be my directrix. And it's 1 wide. So from the focus, I'm going to go out a half and out a half. Does that make sense? So this is actually going to have more than one solution. Do you see that? So you're going to cross in more than one spot. I can tell by looking at it that it's not going to be fun. Let's try it. Let's see what happens. All right. Now my question to you is, would we rather go through and just do all the graphs and then come back and solve, or would you guys rather work on this stuff, the solving algebraically? Half of you are graphs, half of you are solving algebraically. But how many of you are coming to tutoring? Like that? You like that one? Okay, just making sure you recognize. Okay. All right, so I'm going to do this one for you. So this is clearly a substitution problem, correct? I've got a y equals something. So I'm going to substitute this anywhere I see a y. I see a y right there. So I'm going to say, let me use green for this one, red. All right, so I've got a negative parenthesis. My y is really 2x plus 5. 2x plus 5. Correct? Did we see that? Then I have, after I have my y, which is really 2x plus 5, then I have negative 9 equals x minus 2 squared. In order to solve this, we're going to have to FOIL that. okay? So this is going to become, I'm going to combine the 5 and the negative 9, which makes negative 4. 2x minus 4 equals, let's go ahead and just FOIL that out now. X minus 2 times x minus 2. It's a perfect square, right? So shouldn't this be doubled? Shouldn't it be 4x? I'm just going in reverse of completing the square, guys. Right? And it takes a long time to be able to do that, so don't feel bad if you can't. So now I've got negative 2x plus 4 equals x squared. X times x is x squared. Negative 2 times negative 2 is positive 4. Negative 2x and negative 2x make negative 4x. There we go. Now I am going to move everything to that side. So when I do that, I get 0 equals x squared. Negative 4x. When I add 2x to negative 4x, isn't that going to be negative 2x? And then when I add the 4, or subtract the 4, oh, I only have this. When I subtract 4 from both sides, I just have this. So my two solutions, so my graph wasn't very accurate, was it? And we'll go back and look at it. So my two solutions, what do I do with this? You could complete the square. You don't need to because you pull out an x and you get x times x minus 2 equals 0. So x equals 0 and x equals 2. Easier? Yes. Isn't the 4 here? So the negative 2, when I add 2x to this side, it becomes negative 2x. I'm going to add 2x and add 2x, and I'm going to subtract 4 and subtract 4. That's going to give me, I shouldn't have skipped steps. I'm sorry, Michelle. Negative 4x plus 2x is negative 2x, and this is just 0. So then I just have to factor x times x minus 2. So x equals 0, and x equals 2. And now we have to find the y's. How am I going to find the y's? Substitute it back in, right? So 0 and 2. Here's my y. So all I have to do is plug in 0 there and 2 there. So we'll do it in blue. Don't I have two solutions? I have 0 and I have a 2. No, I'm going to find them separately. So y equals 2, 0, plus 5, which is just y equals 5. So this solution is when x is 0, y is 5. And my second solution is when x is 2, it equals 9. So I have when x is 2, y is 9. So let's go back and look at our solutions that we saw. This is why graphing doesn't work as well. So 2, 9. I already knew that solution, right? And my other solution is 0, 5. 1, 2, 3, 4, 5. So it's really, my line isn't graphed very well. And really it should be coming down, and when it comes down, it's going to hit right there, and it's never going to touch the line. Make sense? It only has two solutions. That's why doing it algebraically is so important, because then you can see, oh, my drawing wasn't very accurate. Graphing is not the most accurate way to solve these. Yes? What would it look like? It looks just like that. It's just my graph's not very accurate. It's close. Look at, I definitely found that connection, and so I just should have done that. human error. There's no way from that graph that you would have known it was going to, right? Is there any way possible, humanly possible, that I could have sketched that parabola and known that it was going to cross right there? There's no way. You could do it on Desmos and see it. Desmos would show you right away. Okay? There's no way for me to show you guys how to see that connection right there. There's no way for me to do it. It was actually a good one for us to do to start with. All right, so I'm going to give you the homework. All right? I'm going to give you the homework, and we're going to start working through some of these problems together. Okay? Right? Or would you guys like me to see another? Would you like to see another one? Homework? So this is number 1 on your homework. So do you want to start with the graph, or do you want to start with the hard stuff?
Hard stuff.
I think the graph is smarter because it guides you. Let's graph. Let's graph first. So look, I've already given you solutions. So when you do the hard stuff, you should be able to find these 2 points. Okay? So why don't you, I'm going to give you your homework. Why don't you guys start the graph, and then we'll go back and we'll do the algebraic part. Okay? Sound good? All right. Let me pause it.